I'm Wendelin. I'm the CEO of Virtual Beings. We are a startup based in France, but technically a Delaware C Corp. We have a small team, US-based investors, and we just launched our first game. So just as in yesterday. So it's a crazy time for us. It's a very intense week. Like all of a sudden, like bug reports are streaming in via our automated systems and these kinds of fun. But yeah, I absolutely wanted to do this talk anyway, because this is a topic which is really passionate for me. And it's also close to what we do. So I think by way of introduction, I'm going to let you guys suffer through a very quick trailer of the game. You see how what we do relates to real-time AI, and you get to see some cute animals along the way. Okay, so here, it's called Furry Pets. It's out on the Meta Horizon store for the Meta Quest. And here we go.
Welcome to the Forever Pets Refuge. This
The voiceover has died, by the way.
Okay, so what you just saw in a sense were toys. Like it looks childish, it looks very cartoonish. That's one way to look at it. Another way to look at it is that these are probably the most complex, unscripted, immersive NPCs that anyone has ever built, because the core here is not the visuals, it's the behavior. And you can spend half an hour, you can spend 2 hours with our NPCs, and you will never see the same movement. You will never see the same exact action sequence. And they have a combination of internal drives that make them choose things, but also responsiveness that make them adapt to what the player wants to do. And this is kind of like a dream of mine of like the last 20 years. And I want to preface everything I say today by saying that I'm a person who is really problem driven. I think there are two kinds of developers in this world: those who are more tools and method driven, and those who have an agenda on their own, who are more problem driven. Now, in the age of AI, a lot of developers who are more method oriented, for example, who are intrinsically interested in machine learning, are having a blast. It's a good time to be this kind of developer. I have a ton of respect for that, but I've always started with a problem. For me, the problem has always been how to create like real-time interactive experiences driven by AI, like the ones you just saw, but going much beyond that. And so that leaves me confined at the moment to parts of the AI universe that are a little bit less sexy, a little bit less high paid than the ones that everybody's focused on. Because real time for us is not just a strategic choice or a nice to have, it's a real necessity. So let's look at this distinction between real-time AI and cloud-based AI a little bit closer. Why does it matter? There's at least 4 reasons, like why the two are different. One is inference power. You're always going to have more inference power via cloud-based solutions because you can run bigger models. There's just no competition there. The next one is privacy. Big win for real-time AI. You can keep everything on device. The third one is scalability. you can infinitely scale real-time AI because, in a sense, the user pays by owning the compute that they need. You don't need to incur any cloud-based costs. And finally, latency. And this one doesn't get discussed as much because with a good ping of, I don't know, less than 100 milliseconds and a very, very like responsive cloud-based solution and a data center that's close to you, you can get a full circle query and response from a cloud-based system in under a second nowadays. Maybe you can push it even further, but you would probably have to be Google in order to do that because you need to own the hardware everywhere where the players are. It has to be close. So 1 second latency sounds pretty good, sounds pretty acceptable for most use cases. But for us, it would be a total disaster. There are so many things that are going on with real-time characters that happen in milliseconds to dozens of milliseconds. And what you just saw in our video is an example of that. Everything happens fast. Like if I have a little pet bird perch on my finger and then hit it, or I retract my finger, I don't want to wait a second. That's a weird second if the bird hangs in the air or like has to wait for the cloud ping to decide what it's going to do next. It has to decide right away. Right? Animals are fast. People are fast when it comes to basic reactions. And even when it comes to certain kinds of language reactions, you don't need a second to understand if somebody is talking to you, for example. Like if somebody opens a conversation to you, you will not just process it right away, but you will also respond with your body, with your eyes, with your face, and so on. And that takes dozens to hundreds of milliseconds. And that's important. If we don't have that, then our conversations feel like a Zoom call, like the Zoom call we're in right now, which could never replace an in-person meeting. Right? It's okay for a speech and a discussion, but it could never like create like the kind of close interaction that you need in all other areas of life. So for us, latency is actually the biggest factor, although the other 3 factors are important too. Let's quickly review what you can do when you have decided to confine yourself to this problem like we have, because it is, of course, a lot less than what you can do nowadays with cloud-based AI. But still a few interesting applications. So like a well-known company in the AI character space raised a lot of money from NVIDIA a couple of years ago is Convey. I'm just showing you this this GIF, which circulated a lot last year after the NVIDIA Developer Conference, with awesome looking NPCs, right, with which you can interact. Because of their reliance on cloud, you can basically only have like purely conversation interactions. You can only use voice. Like they have a very nice animation loop, but it's really just that. Like everything you see from the lighting to the behaviors to the face, everything is scripted. Everything is just pre-animated. It's not like really responsive. Whereas if you have tech like the one we're interested in, there's a demo that we showed to investors last year. It's not out, it's just a demo. It looks less fancy, we invested less in graphics, but it shows you how you can potentially interact with a character using not just voice, but voice plus gestures. So, or look direction. I can look somewhere, I can point somewhere in VR, I can ask a question about the things that I see, and then the character is spatially aware of what is happening and like takes that into account into his context. Now, what kinds of models can be done, can be used, turning off the screen sharing, can be used here. There is a range of solutions that you can run quite well. So everything related to speech to text, for example, you can easily run something like the Whisper Tiny model from OpenAI. on device. You can run certain text-to-speech models, so the inverse, directly on device. You can run lip sync models, and you can run like small language models directly on device that do things like analysis of embeddings to already get things like conversational intent. It's not the same as like a full end-to-end LLM, but it does allow you to generate certain kinds of responses directly on device. You can run gameplay code. For example, there is machine learning models via Hugging Face to run two-player games like Othello. There is things like gesture recognition, image recognition. So there's actually quite a few, but you have to probably post-train some of the models yourself, and you are more confined. I think at this point, it would be fun to open up floor and go directly into either a Q&A kind of thing or into a more something like a conversation, because this is about as far as we've got. We have like planned the release in Forever Pets of on-device conversational AI, but in the form of like you call your bird and then it will look at you and it comes to you if you say the right words or if you say its name or if you say things that it understands, which is not full language understanding, right? So we have that upcoming, but we don't have the magic solution yet. So yeah, it would be fun to hear what other guys are building.
That's pretty exciting, Wendelin. Just one question I posted in the chat as well. So I'm assuming like most of these responses are either like textual or can be verbal as well. But are there any responses that are sort of are the animations also generating on runtime depending on the situation, or all of these are text-based responses mostly?
So in our take, everything is procedural. Like we have developed our own AI engine for this. And when I say engine or AI engine, that's more to please like an audience which has a lot of assumptions about AI. In reality, it's more like an operating system. It's an operating system for AI characters that does things that traditionally behavior trees would do, plus offers services, especially pathfinding, spatial reasoning, on-device cognition, synthesis of complex behaviors, and procedural animation. So nothing you see is directly in animation. Animation is a source because you always want the expressiveness of handcrafted animations, but then you mix it up with many dozens of other animations plus procedural code for highly agile limbs, for like the spine to head chain, for the arms, for the legs, in order to adapt the behavior to the situation happening right now on the player's device. So it's actually a little bit complicated, as you can imagine, but the result is that you never see the same thing twice. It's always synthesized. Does that answer your question?
Yep, it definitely does.
Russ Patterson with the Playcraft AI. So we're building similar stuff with on-device models for mobile games, but it's right now we're targeting improving retention. So looking at signals in the player's actions that show they may churn because the game's too easy, too hard, or something like that. So are you building any of your own models on device? Are you finding models? Are you making any LoRa adapters for those models? How are you approaching the what models get on device?
Yeah, we don't train models from scratch, and I think very few people nowadays do. At least if you get to the kinds of sizes that you would want to reach nowadays. But we fine tune to the extent that we have to. The small language model space has really opened up over the last year. There's now interesting models like Google Nano, like some Chinese models that are sub 1 billion parameters. Those are runnable on the kinds of devices we're interested in, especially VR headsets. at runtime. But if you do that at runtime with the 1 billion like parameter model, you still are going to have inference latency that is bigger than the latency you would get from the cloud. So this is not usable for everything. Instead, like
How many milliseconds are you talking about with a big latency?
What do you think?
How many milliseconds when you say a big latency? Like
so it really depends on the use case. If you, let's say you are with an NPC, an embodied NPC in one of our games, you're playing chess, which is one of the mini games that we support in Forever Pets, and you also want to chat a bit, because that's normally what people do when they play chess, right? You chat a bit, right? It's fun. So the super fast, low latency, lowest latency things that you want to do is head movement, eye movement, and gestures. And these, fortunately, do not have to be super precise. They just have to be there. Like as soon as I start talking, I want to have a reaction. Like, okay, character is looking at me. At least the eyes flicker or so. And maybe they cock the head because they're starting to listen to you. Then you have a little bit of a time where you can fake thinking. For example, the character goes like, something like that, while they're waiting for a response. So you could easily like deal with a latency of, let's say, half a second to 1 second for a full conversational turn. But even that is not really possible yet. So we're still talking seconds for like good small language models on device, at least last I tested. And I would like to bring it down to less than a second. One thing that can be done a lot faster. So we have written our own custom code in Unity's inference engine. What used to be called Centis in Unity is now called the inference engine. And you can run BERT-style encoders, which have like between like 80 and 300 billion parameters or so on device. And just by their nature, they are fast. So if you have a good tokenizer, if you have good inference code, like we do, you can get a response in 30 milliseconds on a mobile chip, on a recent mobile chip, which is awesome, because that means that I can understand things like hello, or how are you, or you're an idiot, right? I can understand conversation intent. I can map that to a speech act or a conversational act, something like a call, like come here, like the bird can come here. When I say come here, come to me. I don't know exactly how the player is going to say come here, but I can generate the conversational intent and I can make the bird respond fast to that. Right? That is the kinds of things that are possible. To circle back to your question, Russ, so this does not require a lot of post-training. Like the encoders are actually quite good for that. So we don't need to retrain those.
Yeah, so we're in the mobile game market. We need to hit like $200 devices, so like a Samsung A14 or something, and a few milliseconds. So we're building really small models like MLP classifiers and LSTMs that we're training ourselves on our user data, and they run in a few milliseconds. So, but I really like the idea of the characters, of using them to drive characters, and I think there's a lot of opportunity for that, for creating games that we couldn't play before, now that we have this technology. And that's always what you're looking for in gaming.
Exactly. And what made me excited about this talk and talking to you, who by definition are interested in this concept, is that we start from a constraint. Like all the other companies, like Convey, like InWorld, which raised like a gazillion $billion a couple of years ago. There's a lot of companies in this space now. Like they say, oh, let's start with what Google and OpenAI already built for us, and let's see how we can productize that. So they have this tools mindset, tools first, methods first. Whereas we, or at least myself and my team, we start with the idea, like, what's the problem and how do we need to solve this? Oh, it requires low latency. It has to be on device. Therefore, what can we do here with this constraint? Like, we're probably going to come up with more innovative solutions. And we're going to think more about things like gameplay, things like where's the fun? Where's the fun for players who engage with conversational AI? I don't think the fun is in having a philosophical conversation with an NPC in Baldur's Gate 3. I have not seen a lot of people who have been asking for that. But it is fun to maybe tease or insult your opponent, or to tell your sidekick, like, go over there to the tower and defend me, right? And have them respond quickly, right? That's there's a lot of gameplay potential there.
Do you have any learning layers on the client that store player preference vectors about how they like to play the game or how they interact, so that it's a unique game for all the different users who are playing it?
Yeah, I came in late. I apologize that it didn't show up. But no, you were just saying like I'm very much also focused on what we can do with SLMs, and you mentioned like, oh, gameplay and how fun it is. But to me, the one big one is game consistency, and that's something that's very difficult to get out of SLMs. So it was more just a comment, and like, yeah, if we're going to use this for production, it has to be something that we're confident that, you know, 1 million people, 10 million people can use, and 10% of the time it's not going to go off the rails and break your game or give a bad experience. Yeah,
and my answer right now, you posed it as a question in the chat, is that I'm not
right.
confident it doesn't break. But here's the thing. So this is an area, going back to Russ, I think this is the area where you absolutely have to post-train, and you can probably do a lot. You have to come up with smart constraints, as always. So our constraint is going to be that the NPC is the kind of NPC in this situation that doesn't give you a monologue, that doesn't do complex multi-sentence turns, but that has a strong preference, impacted through fine-tuning, to be short and very situation-focused. And then via post-training and prompting, we try to narrow the answers down to make them gameplay relevant. Also, we so far have always used, and we have good experiences in cutting down the turn length for the player. So the player, when they record a message, and that is then transcribed into text and given to the SLM, they only have like 10 seconds or so to say something. So they are forced to say something that is relatively short, and therefore more predictable than a longer term. Like in 10 seconds, you cannot do prompt injection. I would say, I hope. You can probably not get the language model too much off balance. But you're gonna have some errors, and I think that's okay. I'm not afraid of being imperfect as long as it's fun for the player.
Just one
Yeah,
question
yeah.
about reduce latency. So based on what you have said, it looks like you leveraged speech to text and text to speech, and that is going to increase latency for sure. And have you actually tried to use speech to speech models? It is not using text interface at all. So technically speaking, it is going to be faster, but I believe that the speech to speech model is not at the mature level yet. Have you had any experience with the speech only model?
You just answered your own question, I think. Unfortunately, the models aren't there yet, and the ones that are either not open source or not small enough. We still need to run that model too on device. I am a little bit worried also about controllability. So what I think what Brandon just said, that the problem will only get harder the bigger you make the black box. And what you suggest is essentially enlarging the black box. Now it also interprets your voice, and maybe the tone of your voice is going to bleed into the answers. Then how can I change that model to give it the kind of voice that I need for my in-game character? I know how to do that with a separate text-to-speech model, but I don't quite know how that is going to turn out with a speech-to-speech end-to-end model. And that is, of course, super important for any game designer, right? You need unique voices and you need acceptable voices for your NPCs. That is hard enough for on-device text-to-speech already. So this is only going to get harder. So right now, I don't think we're going to experiment anytime soon with speech-to-speech models. If some big company invests a lot of their money into this, and then open source it, the situation is going to change, but who's going to do that?
Thank you.
Thank you so much, Wendelin. This was really nice. Once in a while, if we do this, like these face meetings, as Wendelin said, like an in-person meeting, the energy, the serendipitous conversation can perhaps never be replaced. But this is the next best thing. So thank you so much for joining and have a good day. Bye-bye.
A lot, everyone.
Yeah.
Bye.
Everyone, bye.